Hello and welcome to Rotary Rocketry. So today I have a really fun rocket building project. You see, recently I've been watching a bunch of the old Godzilla movies because, well, sometimes there's nothing else to watch and they're free on a streaming service. So in one of those movies I saw this missile that I thought was really cool. Here's a short clip from that movie. Now, as soon as I saw that missile, I thought, wow, that's really cool. And I wondered if I could build a scale model of that, but more specifically, if I could build a design that would be stable and actually fly. So I measured the dimensions of the missile on the TV screen as best I could, and I took all that information over to OpenRocket. And it turns out I was able to actually design a stable rocket. Once I had a stable design, I had a construction decision to make. You see, normally we use cardboard tubing for our body, and we use a wood-based material for the fins. The fin gets installed into the tube, and then there's a ring system that gets installed inside to hold the fins in place. Now, I could certainly do that for this rocket, but it's got 3 sets of fins, and I thought, well, this is kind of a different style of rocket than I normally build, so try something a little bit different. So I decided to 3D print the fin assemblies, the transition, and the nose cone. So I used Tinkercad to design all the 3D parts. Now I know Tinkercad isn't the best CAD software out there, but it is quick and simple. I used all the standard settings in the slicer software. The only change I made to the settings was that I added tree supports to the parts where they were needed. It took 93 hours to print all the parts. Nearly 4 full days of print time, and this is what I got. The lower fin, the middle fin, the upper fin, the transition, and the nose cone. Now, I only did a couple of things to these parts after printing. First, I took off the tree support system and I sanded those areas smooth where the supports were located. And then I also installed fillets between the body tube section and the fins. For that, I just used this construction adhesive. Now, this one works good for fillets because it dries nice and smooth. Now, the fillets probably weren't necessary, but I just wanted to add a little extra strength between the tube and the fin. Then I cut out the 3-inch and 4-inch pieces of cardboard tubing that we need to go in between all those pieces. And then we've got a couple of other pieces here that go into the rocket. These two are just motor centering rings that are used to center the motor inside the rocket. We'll talk a little bit more about the motor in just a little bit. And I 3D printed a little stand that will help us get these glued in place in the proper position. And then we've got the motor bulkhead, which is just the piece that the motor pushes against in the rocket. And there's a little cardboard tube that goes above that to reinforce that so it doesn't get pushed out of place. And then we've got the parachute bulkhead, which is where the parachute attaches. And again, a small cardboard tube that gets installed above that so that it doesn't get pulled out of place when the parachute ejects. And then we've just got the 2 rail guides for launching the rocket. The first one here is already installed onto the upper fin, and we'll install this second one here onto the lower fin after we get some other parts installed in there. Now, the motor we're going to be using to launch this is our Super Monkey motor. This is a PVC case motor filled with Flexi Fuel sugar fuel. This has been a very dependable motor for us and typically gets our 4-inch rockets to around 1,000 to 1,200 feet. Now, this rocket should be just a little bit lighter than our 4-inch rocket, so I'm hoping for a very similar launch altitude around 1,200 feet. So basically, we just have a kit here that just needs to be put together. So let's clear everything out of the way and get started. The lower centering ring gets glued into the bottom fin assembly, and I've got this little 3D printed part here that will hold it at the correct height so we can glue it in place. I'll show you a close-up of the inside of that. Now, to glue these parts together and to glue all the parts that we're going to glue on this rocket, we're going to be using the Loctite PL construction adhesive. I like using this product for 2 reasons. Number 1, it's really strong. And number 2, this product actually expands a little bit as it dries, and that helps kind of fill any cracks and crevices so that it gets a really good bond. All right, so I'll start with just putting a thin coating of construction adhesive right at the location that I know where the ring is going to be positioned. And then I'll place the ring on top of our tool here and just gently slide that into position. Now I can take just a little bit more construction adhesive and just run it around the top of the ring. I'll show you a close-up of that. Now I do need to let that construction adhesive harden for several hours before I remove that positioning tool, because I will need that same tool to install the second centering ring into the middle fin assembly.
Later.
All right, so that looks great. So we'll do the same exact thing with the second centering ring and the middle fin assembly. That looks great. We'll let that dry for a couple hours and we'll move on to the next step.
Later.
So that's had a few hours to dry and it looks really good. So we're done with this piece here. Next we need to glue in the motor stop and the cardboard ring that goes on top of it. And that just gets glued into the top section of this fin. So in order to hold this in position, I've just cut a little piece of PVC that slides up through that centering ring, and that allows us to drop that bulkhead down on top of there to hold it in position while we get the cardboard ring installed. So I'm just going to go ahead and put a layer of the construction adhesive around the inside of this part here. Okay, and then we'll just place that piece in there so that we can push that bulkhead down in position. It's going to take some of that glue with it as it moves down, and that's okay. That'll just help glue it in place. But it has removed a lot of the glue that we had around here to hold the cardboard tube in place. So we'll put a little bit more adhesive in there. And then I'm also going to put just a thin layer of construction adhesive all around the outside of this cardboard sleeve. And then I'll just pinch that so that it fits into the part and slide it down as far as it can go. Now right now it doesn't go all the way down because that PVC pipe is holding our bulkhead piece up just a little bit. So I don't want to glue this to the table, but it's okay if we accidentally glue it to a paper towel because we can just tear that off later. So I'll just take this piece, we'll take that PVC pipe out and push this down just until it seats the cardboard ring all the way down level with the top of the plastic piece. Now I can also get in here reaching through the centering ring and just put a thin layer of the construction adhesive around the bottom of that bulkhead. Then we'll just give that a couple of hours to dry.
Later.
Okay, so that came out fantastic. So the next step is to glue all three of the fin sections together with the tubes in between. Now there's a lot of connection points here that could allow for some wobbling or some crookedness to the rocket. So we need to be very certain when we glue all this together that the rocket is perfectly straight and that all of the fins are aligned. I've got something out in the shop that I think will help with this, so let's head out there. So the first thing I'm going to do is apply construction adhesive to all the parts.
The next day,
By supporting and clamping the rocket this way, we're able to ensure that the rocket is straight in this plane and in this plane. And because all the fins are clamped to the same surface, they're all aligned. Now I let this sit overnight because I wanted to be absolutely sure the construction adhesive was completely hardened. This is ready to head back to the workbench. This is looking great. So the next thing we need to do is glue the last piece of 3-inch cardboard tubing on top, and then we'll take the parachute bulkhead and glue that down inside there. Now that slides down in here and it stops when it hits the top of the fin piece. And then we'll glue in the cardboard retaining ring that goes in on top of the bulkhead to keep it from pulling out. Now I don't want to glue the transition on here quite yet because I don't want to take the chance that the parachute mounting hardware will fall in and get stuck in the glue that's in there. But what I can do is glue the 4-inch cardboard shipping tube onto the top of the transition. I'll give that adhesive a little time to set up on both of these parts, and then we'll be ready to attach them together.
later,
Now I'm ready to install the transition onto the top of the rocket. Now to make sure that this is straight, I took a framing square and I attached a long straight edge to that so I can hold that against the bottom section of the rocket and check the spacing along this upper section here. And I see that it's definitely tipped to one side just a little bit. Now that was kind of expected, that there might be some error there just because of the glue joint here at the top of the fins or the glue joint here at the top of the transition, or it could be that one of these cardboard tubes just doesn't have a perfectly straight cut. But that was expected. So I cut out a bunch of little thin paper shims, and I placed them around in this joint here, and I found an arrangement that made it so that it was straight in both directions. So I've got those shims ready. I'm going to go ahead and put the adhesive on this, and then I'll insert the shims and double check to make sure that we're perfectly straight. So that looks really good. I'll give the adhesive some time to harden up, and then we're just about ready to do the finish work on this rocket.
Later.
This is coming out really nice. Now the next thing I need to do is drill some vent holes in the body of the rocket. Now if you're not familiar with why the rocket needs to be vented, let me take a moment to explain. We're going to be using a flight computer with this rocket. And the flight computer detects when the rocket reaches apogee. When it reaches apogee, the flight computer will fire an ejection charge, which will eject the nose cone, which will then pull out the parachute. Now, the flight computer needs atmospheric pressure to be able to get proper readings. And the flight computer is installed into the nose cone. Now there's a vent hole in the bottom here to vent that flight computer chamber down into the body of the rocket. And that's why we need to vent the body out to the outside so we get the same pressure on the inside of the rocket as we have on the outside of the rocket. Now it's not a good idea to put vent holes up at the top very close to the nose cone because of the way that the air is typically pushed out away from the rocket at high speed. So I'm going to come down to the bottom of this cardboard tube here just before the transition, and I'm going to put 4 vent holes there. And then I'm going to come down to this section here below the transition. Now inside here is where the bulkhead is installed for mounting the parachute cord, so I'll come just above that mounting point and put another set of 4 holes there. And then I'll come down to this middle section and put another 2 vent holes in there. So I'm going to take this out to the shop to do that. Now the rocket's ready for painting. Now we're going to paint it as closely as possible to the missile in the movie, which means it's primarily going to be white, but before I put on any color, I'm going to put on a coat of primer. So this rocket needs a parachute. Now, I've got 3 parachutes I can already choose from. If you saw our previous video, I purchased 2 parachutes on Temu.com and we tested them as recovery parachutes in a rocket. Now, one of those Temu parachutes is just too large for this project and would result in a very slow descent rate. The second Temu parachute is a little extra bulky because of a nylon webbing that's stitched into the canopy. And we just don't have very much room in the parachute bay of this rocket for a bulky parachute. My third option would be our homemade 5-foot diameter ripstop nylon parachute that we usually use in our 4-inch Eliminator rockets. That would work well for this project, but I think I want a parachute just a little bit smaller than that. So what I've decided to do is take the 6.5-foot diameter Temu parachute and cut it down to 4.5 feet. So let's go do that. Parachute's finished and ready to go.
I'm almost into the main frame. I'm in.
Hey, you don't have to hack the system to get yourself a Rotary Rocketry t-shirt. Click the link in the description to access our shop.
Hey, check this out.
Available in a wide range of colors with a variety of graphics. Get yours today.
Okay guys, it's launch day. Now when we're testing something new, I'm always a little bit nervous, and this one is no exception. The software says this is a stable design and it should fly, but we'll see. Now if you're interested in some technical specs, this rocket weighs 1,230 grams without the motor installed, and it is 1,705 grams with the motor. And it is a total of 39 inches tall, which to my best estimate is about 1/4 scale of the missile that's shown in the movie. So we're going to get set up and hopefully have a great launch.
Three, two, one.
Oh shit. There we go. There it is. Perfect.
Now that may not have looked too bad on video, but trust me, that was really bad. The rocket was wobbling violently the entire way up, and because of that, instead of reaching the expected 1,200 feet, the rocket only flew to 330 feet. Now, would I say that's a success or a failure? Well, in general, it was a successful rocket launch. The rocket went up, the parachute ejected, and the rocket came down perfectly safe. So, what went wrong with the upward trajectory? Well, this rocket has some inherent design problems dealing with weight distribution, center of gravity, fin size, and even fin location. And all of those will have effect on flight performance and stability. Now, I may try to rebalance this rocket and fly it again in the future, but I think for today we're going to wrap it up right here. I had a lot of fun building this rocket, and I really love how it came out. I hope you enjoyed the video. Don't forget to like and subscribe, and check out the full line of Rotary Rocketry t-shirts. There's a link to the shop down in the description. Thanks for watching. We'll see you next time.